Yeah, the truth is, I created the slides in the train before. And there are lots of slides because I thought what to do. And I'm back from another small conference, it's called DevOps, so I showed more code. And I think I would like to explain you some higher level ideas because I was widely misunderstood what I mean by what is now the role of open source in the cloud, for instance, right? So there's two different architectures. So it is going to be higher level, but I also have source code on my machine, so I won't code too much today, but I can show you lots of source code. So if you don't ask any questions, I'll show you lots of slides. If you ask me questions, I could show you the source code. So this is the interactive talk. So I was invited here at the JCon conference. And the funny story is, this slide happened on JCon because someone asked me, are you working for the company called AirHacks? And I said, no, this is just a website. AirHacks is just my invention. The story is very simple. I wanted to submit something to Maven Central, and Adam-Bean is not compatible, so I need something one word. And this was AirHacks, so it was the original idea. So on the AirHacks Industries, if you go there, you will only find links to GitHub, to YouTube, or whatever. So this is the JCon reminder, but actually fun. So I like Java, and I also maintain a podcast. And the interesting part is the last things, for instance. So I like a little bit to know Java history or Java E and why it is important. And the last part was about how JAX REST, for instance, happened. This is like the REST endpoint, which is very successful. And yeah. And I don't know whether you know the boundary control entity, which I propagate. It was also an interesting episode with the guy who invented boundary control entity. And this was Eva Jacobson. And he's, I think, over 80 and still enjoys coding. So one of my idols, this is what my secret plan. Just stay code the entire time. And, 50, 60 years, I also will be 80, and then I could code also still, right? So this was the idea. So any questions left? AirHacks TV, first Monday of the month. I'm just answering questions online. Sorry for the ads, but this is also fun. I create daily Java code snippets, usually with questions from the community. And the cool story is someone wanted to have, HTTP client. So I hacked the HTTP client for him and say, why you need to have it? You need it for work? And I said, no, but for Minecraft, for instance. So Discord, some workshops, and now start with the content. My official introduction is like this. So I started with DevOps in 1995, so it is possible, very easy. There was one of the first server-side Java projects because it was, servlets came 1997, and I waited, January the 1st were released the Java web server, and I waited for it. And then I had the Java web server, and I wanted, to use it. And in the company in Germany, they told, okay, but we don't have server, what we should buy? So, okay, Sun would be cool. So I know it's too expensive, so they bought HP, but we had to install everything. So this was actually, we didn't call it DevOps, but we were responsible for the entire thing. So from the box, I know, one guy did a relational database training, and then we built together the entire stack, and we were responsible for run it. So if it broke, we were cold. So it was like DevOps. What happened then, of course, people got the idea to split this, and then was one department who ran the server and the other one who created, and then after 10 years they forgot how it was 10 years earlier, and then they reintroduced DevOps and merged it together. So this was the entire short story of Java. So, and then after DevOps I did serverless. Why? And this is no kidding. Why this? We were no more allowed to touch the server, right? So we were serverless. And no kidding, if you think about this, the first clouds, my idea was to pick, and this is the first OpenShift. You have a Red Hat guys here. The very first OpenShift worked like that. I remember you had a GitHub, I think Git account, this was like 10 years ago or more than that. It was not compatible with the current one. This was a proprietary implementation, not based on Kubernetes. I don't know what it was based. It was very similar to Heroku. But you put your war or source code in a folder, and it created everything for you. So it was like serverless on steroids. So, and this is in the puristics form, it is serverless. Period. So so as long as I worked for a large company, I was not able, for instance, to tune the database. I was not able to touch the database. We just got, the JDBC connection, and then we could access usually Oracle and DB2 back then. And since 5 years, Postgres is, I would say, the huge winner. Everyone migrates to Postgres, or at least my observation, right? So, so if you think about this, so if you are in a large company and you don't control the database, you have actually a better development environment than in the cloud. Because if you go to the cloud and you would like to have a relational database, it is hell on earth, right? So until you have it, you have to be expert in networking, IP addresses, subnets, NAT gateways, and security groups, and whatever. So this is actually the point, which is widely misunderstood. Many people think if we go to the cloud, everything is easier. The truth is, if you go to the cloud, everything is harder and possibly even more expensive. Okay? So this is the basics. So first, Green IT, very important. This Green IT happens to me 2 years ago, started, and everyone, and the peak was last year. Everyone asked me about Green IT. It's like, why you are all so interested in Green IT? Because for years, no one cared. And last year, we would like to have Green IT. So I get a workshops about Green IT. And first, Java does great. So this is an official, this is a study. If you go to the URI, you will find, if you're interested, all the algorithms. If you take a look, Java consumes, it's at fifth place after Ada. Rust is better, but Go and all the funky languages are way worse than Java. So what it means is, if you go to the cloud with Java, you are greener, 35 times more greener than JRuby and Ruby. So the Python is terrible. So if energy consumption it consumes 35 times more energy than Java. So it's very bad for the environment. So if you keep using Python, that the trees outside will disappear. So this is like what we can tell you, right? So this is will be set conference next year. So my take is the second row is more important for managers. It means Java is also way faster than Python. So what it means is, if we are in the public cloud, we can save money with Java. This is where every manager listens to me, money. But if you are on premise and you are faster, you can have more density on one hardware. So you can also save money. Okay, now GraalVM or Mandrel from Red Hat. This is, if you're just interested in native image, you should use Mandrel. This is like a downstream project, right? Downstream, confused downstream and upstream. So it's like, the fork of GraalVM without polyglot. And if you introduce, so Java is really bad if it's bad comparing to C. It consumes 6 times more memory than C, which is actually cool because it is 35 times faster than Python and consumes 6 times more, only 6 times more memory like C. So it's not that bad. But if you use GraalVM, it is comparable to C. So on OpenShift on premise, I would say OpenShift or Rancher or whatever on premise, we always use GraalVM to have a higher density. In the cloud depends on the cloud. On Azure, on AWS, almost never. On Azure depends on an SKU. Sometimes it is worth to use GraalVM optimization. Worth means cheaper. Okay. Costs is the most important factor. Hi. So now this is the nice, this is actually the reason why I got so many questions about the Green IT. So always the joke if, Emily, read this. No, you have to read this. Can you? Very good. So this is exactly Lieferketten-Sorgfaltspflichtengesetz. It's impossible to remember. And this is why it sparks, at least in Germany, the interest in management. Because now it comes, I didn't know about that, I have to say, because in one project I say, why the hell you are all interested about Green IT? And the manager said LKSG. So what is it? Search for it. So I searched. So this is the German. I translated it to English. And what it means is, starting next year, all big companies have to show how they consume, data center, the CO2. Important part. If you run, your, your monolith on Itanium, with 2 megawatts, then it looks worse than if you do some smarter things with whatever we have, right? Okay, now microprofile I/O. So why I show you this? Because in all my projects, we are using microprofile I/O in Jakarta E, actually. I don't talk about this that much, because it's more like I don't talk that much that I run on Linux, right? I mean, how often can you repeat that? But actually, all serverless projects or on-premise projects are microprofile and Jakarta E projects, or Java SE, so nothing. So either we use microprofile, or we use HTTP 11 client and nothing else. So these are the two modes, okay? So what is microprofile in Jakarta E? For me, it is like Linux. It's like, stuff, don't talk about it, just use it and it works. So boring technology. So interesting part is, depending whether we are running on the cloud or not, we use more or less of microprofile, for instance. On-premise OpenShift, we use everything, almost. In the cloud, less so. Why? Because we go to the cloud the expectation is that the cloud does more for us, right? This is the idea. Okay, this is the Jakarta E core profile. And the Jakarta E website is terrible, because you cannot find anything there. So this is like a screenshot from the spec. So what it means is people are not, or I get asked, what's my opinion about microprofile, and what's my opinion about Jakarta E? For me, it's no distinction, it's one thing, I don't care. Because if you have a microprofile, I have a part of Jakarta E there. This is the CDI. And I only need CDI, and I'm happy. And whether the CDI belongs to Jakarta E or to microprofile, I really don't care, right? So my project is like, I use a microprofile config in Quarkus, for instance, with CDI arc from Quarkus, but actually it is Jakarta E, but who cares about that, right? So, yeah. Because no one cares, just use the standard and hope that it will survive the next 10 years. So far, it worked perfectly. Lots of projects had to migrate, and people come to me after 10 years, like there was great choice what they did 10 years ago. Still it works, we can just focus on the business logic and not on funky frameworks. Also cool, I forgot to mention, this Airhex TV, it has already 160 episodes. What it means is, it runs for almost 10 years, the show, monthly. What we do, we look 100 episodes back and look at the questions, 8 years back. And there were questions, why are you using Java E and not the other framework? Like, for instance, Play. What the cool story is, all the frameworks 8 years ago is almost dead. And there's one nice guy from Brazil. He rewatched all the shows and tried to keep me honest. Like, okay, you said this and this, and this is actually a cool community. So so we are revisiting 8 years old questions, and you get the same answer now than 8 years ago. So there are small differences, but usually it is surprising how well it actually does. So I got a really nice slides from Eva. He is in the last row. So I say, hey, Eva, I cannot find on your website anything. So okay, then I'll give you a screenshot from you. So I got it. This is the freshest page from my entire presentation. And this is the entire thing, which is Jakarta 11. So what I usually do is CDI Lite without knowing, or dependency injection. Interceptors depends, usually not. In my current project, we do the entire token or OpenID connect with that. There's a specific case. JSON binding and JSON processing actually almost always. Interesting is if the API, or how to call it, if we have multiple versions of the same API, I tend to use JSON-P. If the project is more boring, we use JSON-B. So what it means is, in more, I would say, streamlines, or how to call it, more simple CRUD projects, we have Java classes with JSON-B annotations, and we expose it to the outside world. And in more challenging projects, we use more or less a JSON object, which looks like a hash map. Okay? So this is what happens. So I saw these slides half hour ago. So I have to what RESTful web services always. Enterprise beans Lite actually never, because Quarkus doesn't support that. And I'm waiting until Micronaut is microprofile compliant, so we'll use maybe microprofile more. And validation sometimes, it really depends on the projects. WebSockets on-premise, yes. In the cloud, not always possible. Because if you are, for instance, on AWS and you would like to use WebSocket, you're usually sending events to the HTTP API gateway. You cannot just expose your WebSocket stream. So it is technically not possible. Persistence, interestingly, so I have to speak faster. Persistence, it depends. I like JPA a lot, so I would always prefer it. And for instance, who uses Hibernate, who use Hibernate directly, curses right now, right? Because they cannot easily upgrade from 5 to 6. But if you use JPA, no problem. So JPA abstracted everything, so it was actually a huge advantage using JPA over directly be depending on Hibernate. This is why I don't like Panache a lot. For instance, I also prefer JPA. Panache is like a proprietary active record framework from Quarkus. Looks good, but it's not a standard. And I say, okay, as it's not a standard, in 5 years, who knows what happens, right? So persistent. So in the clouds, interestingly, we are not using JPA a lot. And this is not why it doesn't scale or whatever. The problem in the cloud is, in the cloud, we will have to install a relational database. This is not a problem. And care for it as developer, and this is a huge problem. You have to back-end the costs. Raspberry Pi, database, €1,000 a month, at least. So what happens is, in the cloud, I usually don't use JPA. We use proprietary databases, usually Cosmos DB on Azure, or S3 DynamoDB on AWS. So this is what happens in the cloud. And we don't need any abstraction. We just go directly to the API. So servlet is less common right now, because most reactive frameworks are not more servlet-based. They are exposing JAX-arrays directly. By the way, you have to ask me at least one question, right? Because you say everything yes, and then the deal was. So, and you see how well I prepared. This slide is like I got from Eva, as I said. Half an hour ago, mail I use actually a lot to send mails, not to receive mails. And batch, never use that. And activation, had to use this if I use mail. And authorization is interesting. So in the cloud, on-premise, we always use Jakarta E authorization, and it was extended with OpenID Connect on-premise. In the cloud, we only use microprofile JSON Web Token. Why? Because the expectation is that the cloud cares about security, passes the token to us, and we're using Quarkus the token. So in the cloud, I never use Jakarta security. I mean, parts, the annotations. But how to call it? The authentication, the profile, was encoded in JSON Web Token, and nothing else. No HTTP mechanism. This is a little bit dangerous, yeah? But OK, so this was contribution from Jakarta A to my slides, so thank you. Now, this was my first project, one web server and many wars. So what was the use case back then to save money? They bought a huge machine, put wars on it, years back then. And huge machine means that there was, for instance, the Sunfire E10K. It cost $1 million, and it was bought by, there are 2 such machines in a company, and everything was put on the machine. So this was the idea back then. So, so this was my first server. I found it, actually. This was the Sun Java web server. And so the evolution was application server, like the first JBoss, for instance, web container, EGB container were separated. Then they said, no, bad idea, there's one. And then there is a CDI on JAX-arrays container. Then they said, OK, we have microprofile. Then we have microprofile with one. And then I was like, this is a good idea. This is the microprofile or microservices. What it means is one runtime, one war. And I wrote actually back then, maybe 10 years ago, a blog post that actually for me, microservices is one application server with one war, and it works perfectly. And it still works, right? Docker, and now it comes in the cloud. This is the entire hack. What we use AWS Lambda or Azure Function and put exactly the same code as Lambda, and we can sometimes drop the price by 90%. So what for me, clouds are not revolutionary. Actually, the code often looks really terrible in the cloud. But if you are in the cloud, everything is about costs. This is a huge difference. So, and this is misunderstood. It's not like you go to the cloud because you would like to do something beautiful. You go to the cloud either because you don't have a choice, or you would like to minimize the costs. But you cannot minimize the costs with lift and shift. Lift and shift means, pick your virtual machine and launch it in the cloud or Kubernetes. So this is why I have to admit, yeah, this is true. We always migrated, if there was private OpenShift, we migrated to not Kubernetes environment in the cloud, to serverless. I was never in a Kubernetes project in the cloud, what I initiated. This is the interesting observation. And why? Costs. For a small Kubernetes project, you will pay 500 euros a month, for instance. OK? So what it means, we have microprofile, and it runs in containers on Java SE or AWS Lambda. So this is how it looks like. What we pick only depends on the expected performance, project load, so how many transactions per second. So what it means is, for all enterprise projects, serverless, with microprofile, you get almost for free. Because you have 2 transactions per second the entire month, and this is a lot, day and night. We do the math several times. You will pay roughly with microprofile, full stack, maybe 10, 15 euros a month. Usually nothing. If the load increases, in one point of time, EC2 and then Kubernetes is cheaper. So, and this is what you have, to calculate the costs. So this is the basic idea, right? So containers, we try to avoid. Why? Because you have to care about the containers in the cloud. So you have, to have the super image operating system, and everywhere there can be some problems, security problems. And what I don't like, to be scanned, and the old compliance and audits is a little bit problematic. So the best thing is, I just put like 20 years ago my war to the cloud and I say, do the infrastructure by yourself. So what I would like to back, have my 1995 back, yeah. Docker, yeah. Docker is just like containers is more than Docker, like, the Docker runtime. Is this Cloud Runner? Cloud Run, I think GCP is similar. Yeah, but the cool story is not in microprofile, right? So if I show you the code, because you asked questions, so I will show you the code. This was the deal, right? So for instance, this is an old project from me. And it was actually the first commit was 10 years ago. It was a Java 1, I remember. It is a monitoring tool for Glassfish back then. And why I'm showing you this, because if I show you here the source code, you will find that actually the source code looks like, I'll show you in a second, source code of my Lambda. There's no difference. So actually what we could do, we can migrate 10, 50 years old source code, starting with Java 6, which is old, to Lambda without any problems. And the trick is, what we're doing is here, I have here an example. I cannot show you the real thing, but I rewrote it actually. And as you can see, this is a Lambda, and this is CDK. And if I go to Lambda here and open this and show you the source code, you will find that this is, you cannot know that this is a Lambda. So there is no specific API, it is microprofile. So what's the trick? So what is the dependency to the cloud? And the only dependency is the following. So if you go, this is Quarkus. And if you search here, you will find here Quarkus Amazon Lambda HTTP. If Quarkus knows the extension, it packages it differently and ships everything as a zip. So it means what we can actually do, the slide before, or we, I mean everyone, right? No, it's not like it's something special. You have one Quarkus who's on profile, and you can ship at the same time bare metal, Docker, and Lambda. And we misuse it for, I'll show you what we do with it, for debugging and testing. It's also later on the slide. So what I can do, I can say Maven, Quarkus, and dev. And the expectation is that it starts. And what starts locally is Quarkus in local mode. And if I push it to the cloud, it is a serverless Lambda project. So I have no idea about GCP, but on Azure it's the same. The only difference on Azure is you will use a Maven plugin, not an extension. And the cool story is that Maven plugin is even implemented by Microsoft. So what it means is that the code is always portable. What happens, the Quarkus gets a different event from Azure and different event from AWS. And on Google, I have to do some research because Google in Germany is unusual as a cloud. So it is, I only know one project, big project, which is Google, and they don't use Cloud Run, they just use the Kubernetes. And by the way, my opinion, Google ships, or Google Cloud has the best Kubernetes support. So it's really convenient, and the others cannot compete, actually. This is my personal opinion. This is really nice, as it should be. Thank you. OK, now I'm back to slides. So what it means is, this is the only technical slide. It means if we are application servers, this is the only difference. On Java application servers, there is this is no more true because we get reactive programming, but I mean, forget reactive. In classic, you get one request, one thread. In the cloud, the only difference, but this significant one, If you go to serverless like Lambda, Cloud Run, or Azure Function, you get this. This is one request, one process. And many thinking that Lambdas, for instance, or Azure Functions or whatever, are a toy, because one function or whatever. What it means is one registered function. What Quarkus is doing, Quarkus registers itself, and it dispatches the event to JAX-RS. So you can have hundreds of JAX-RS endpoints with one Lambda function, which you don't even see, because it's implemented by Quarkus. By the way, Micronode does the same. So Quarkus and Micronode have very similar capabilities. Quarkus is farther, and Micronode does not support microprofile completely. So if you always should send how it's called, Graham Rocher, an email. We would like to have microprofile, so then it comes faster, right? So so on-premise and private cloud. So what it means is, from my perspective, Jakarta E can be used on-premise in the cloud. And by the way, there is actually not that clouds are better, or on-premise is better. For me, if you are on-premise and you can stay on-premise, I will always stay on-premise. I can, very conveniently go to my server and do whatever I like. In the cloud, everything is way complicated. But what are the advantages of premise? So you can access your server directly. So now it comes, compute and storage are nearly free. So I'm buying the most expensive server, actually, I could find on AWS with my own parts just for fun. And it's always cheaper than 3,000 euros without graphic card. I don't need a graphic card. So for 3,000 euros, you get, really custom chassis. Try it. The best CPU, SSDs, NVRAM. I had always the newest and funkiest stuff. For 3,000 euro, if you do it in the cloud, you will spend it in the first month with similar hardware, for nothing. Okay? So the problem is there are crazy, departments prices, inter-department prices, pricing or calculations, which are not realistic. But actually, hardware is pretty cheap. So automation on premise is hard. This is problem. You cannot automate anything, or really hard, right? You could do this if you have OpenShift or something similar. You could automate with Terraform or Ansible, but it's harder. So because there are no management or control planes APIs, this is the huge difference to the cloud. Then you can run as a root, which is a big problem. Always saw this. Everyone tries to run as a root. This is, yeah. And the problem, of course, is always on. It does serverless. The question was, we can do serverless on premise. If you think about this, it doesn't make any sense unless you are huge. If your company have a huge data center, with over-provisioned data center with lots of spare capacity, then serverless could make sense. But usually, if you think about it, serverless has actually been more inefficient because it always starts and stops the resources. So if you are on the heavy load, Jakarta application server, it is always more efficient than a Lambda which starts and stops. You remember back then, message-driven beans, they start and stopping, there were always 3 transactions required. The overhead was more than one session bean, which was called directly. Agreed? So what's the trick with serverless? If you have hyperscaler like Azure or AWS, then they can pick and choose machine which is idle and then run the Lambda there. This makes sense. So from my opinion, if you are on premise, just start on bare metal. Yeah.
So would it mean that was beneficial to have a hybrid on premise? Actually, this was scenario you saying, yes, for the base load, be on premise, and then you have to scale.
For costs, it depends. In my current project, for instance, we have the different problem as well. If you sometimes you have requirements. So why I'm doing all the time public cloud? Not because of that. The next thing is audits and compliance. So they will ask, show me all the papers, and you don't have anything for your local data center, and the clouds have everything. So that's the next problem. Then disaster recovery. So every cloud I know, they have multiple data centers, and you can run the application very easily on all of them. On premise is harder. So this is usually what is. But pricing-wise, you have to calculate it. It's really hard to tell, right? But it's going to be hard to have both, because then you need some direct connect, or express route is the name of Azure, which connects your data center to the cloud. But it's doable. Yeah. But the cool story is, there was I do the AirHacks workshops, and there was someone from Australia actually participating in the workshop, this online workshop. And what they are doing, they bought the largest EC2 machine they could, and they put an application server on it, and put lots of wars, and they said this was the cheapest possible solution, which I really believe. Because if you pick EC2, this is an S3, this is the lowest level. So serverless will be always 30% more expensive than bare metal machine, has to be. There are no wonders, there's no miracles. But the trick is, if you have an enterprise app, you have Monday to Friday load, Saturday, Sunday, nothing. So the entire trick of serverless is that a serverless is like the perfect, how to call it, auto-scaling. If you call the service, it is called. If it's not called, it is dead. This is the entire trick. So it means for most enterprises, it costs us nothing comparing to Kubernetes. But if you get something like TikTok, EC2 will be always cheaper. Okay? Cool. So we have departments, and we have multiple departments, and this is serverless. And I would say, for that, Jakarta E and microprofile suits beautifully. Because one department runs the server, we only need some FTP or whatever to put the wars, and you are done. So if you think about this, the application servers were always about being serverless. And what I missed in application servers, like deployment API, what I wanted to have a standard deployment API, so you can put, this was the missing part in my projects. Okay? Okay. So what it means is, on-premise, you have relational database, you have message-oriented middleware, Kafka, you have IDP, NAS, backup. Everything is already there? Yeah. What we did, I don't know what the startup did in Australia, but what we did, we played with security manager. We activated what happens, right? So if you activate security manager, you see that someone tries to access Java I/O or something like this. But I'm just saying. No, but what I thought already. So in the cloud, there's a scheduler. So the schedule is unsolved because it cannot run it in one instance. You have to run something which is global. So the clouds comes, Event Bridge supports it natively. If you do something more involved, I already thought about having an application server on EC2 with my own scheduler, and I put, the wars which are scheduling or invoking other things. This could be very interesting, actually, because this is your own choice. So you have the same, the same war. What you put, what they're doing. It doesn't have to be open. Most of my projects are private, in public clouds, but enterprise projects. I'm not working for YouTube. This completely was different, right? So it is not like software as a service, but if you know what they are doing in a company, of course you have to be careful, right? But the problem, Lambda is the same. If you have endless loop in a Lambda, you will pay overnight 1 million euro, not 1 million, but this is the problem is everywhere. So this is, yeah. What I'm just wanting to say is not like black or white. Yeah. Yeah, this was deprecated then. Yeah.
Well, technically it did exist. The only reason it wasn't used so much because nobody was using it. It was like a kind of circle reasoning. It wasn't used because nobody used it, and then it was just.
Yeah, what I use a lot in Glassfish, the RESTful service to deploy stuff. So I wrote a wrapper, and I had always bad feeling because it was no standard. It's like, why there is no standard there, right? But I just wanted, it would be very simple, like no update new version. This is what I always used.
Yeah, and then we had two other projects, like Killian, which can be used to just deploy the bar. So everybody thinks about it as a very elaborate testing framework with a lot of magic, but it also has a feature to just deploy a bar.
Yeah. It was not a Killian, it was the thing which created the jars internally. How it's called, there was like, you could say, create a jar from all the classes. This one's Killian, this was shrink wrap.
Yeah, shrink wrap, but you can also just, using that, build just a grab existing bar and upload that. And don't care about micro or
Yeah, cargo. Yeah, Apache cargo. You are right, cargo. And you are basically the Java E security guru, right?
Yeah.
He was one of the committers. So if you have questions about Java E security, ask.
Yeah.
Exactly.
But yeah, so they with Cargo and Affiliate and JSR88 together.
JSR88, exactly. Those are the deployment API.
Yeah, there were options, they were just a bit scattered.
Yeah, because this was not promoted. It's like Genie was completely wrongly solved by Sun, right? So if there were more push, so I would say this would be this is great community opportunity. Because what I missed, why there is no Jenkins, and the Jenkins pushes directly, this would be cool. So yeah, could be improved. So on-premise, what I will do as a company, you have complete different possibilities on-premise. You could do crazy stuff like Java Flight Recorder. You can set up the entire thing, and monitor whatever you can. So you get the best monitoring. None of the cloud providers could keep up, actually. Because they're not about Java. If you know that we do Java on-premise, we could set up the entire instrumentation, and no one could actually compete. We got the best possible monitoring instrumentation. Cool things like btrace and all the dtrace. You can instrument whatever at runtime. You could also do it. Then logging, ELK, the entire logging infrastructure on premise, you cannot do it in the cloud because it gets really, really expensive. So on premise, you can actually the logging costs in the cloud, they are huge. So on premise, you can log far more fine detail, but it's also not used by many clients. Monitoring, you get Prometheus for free. In the cloud, you pay a lot for Prometheus installation. On premise, costs you nothing, right? Then you can also have OS and JVM integration. There is, for instance, there is EPOL and IO ring, for instance, of Linux. What Quarkus is doing like crazy with the Vertex. You cannot do this in the cloud because in the cloud there's always abstraction. So what I'm saying is, if you are on premise, do on premise use the features which are only available on premise and not in the cloud, right? This will be the idea. So what's the main difference now? On-premise, open source is very important. Why that? Because we would like to be not vendor dependent. So we use JDBC and JPA, not to be too much depending on JPA, on Hibernate or Eclipse Link, right? So this was the main idea. So it means, but I would say microprofile and Jakarta E solved the problem because you are always working against the APIs. And in code reviews, what I do, if I see Orc Hibernate or Glassfish persistence, which is old one, or Eclipse Link, I say, okay, what are they doing here? Why not using JPA? Why not using, for instance, REST easy, forbidden, Jersey, forbidden. So if you just go against the APIs, you are more portable. For instance, Hibernate, 5 to 6, nothing to do if you use JPA. So I think this is a great idea, and to my knowledge, so microprofile and Jakarta E are great, because they provide us the API, and so far I know all the developers really use the API and are not depending on the implementation. So, yeah, what do you have? Cryo, Crack, you have Kubernetes, Kafka, Keycloak, Jaeger, Minio, Terraform, Ansible, Elk, and so forth. You can just run it. For instance, on-premise, using Keycloak, no-brainer. If you use Keycloak in the cloud, a little bit problematic. Right? So how to patch it, how to run it, where it runs, what is about the persistence, what about the cluster. So it is a huge problem. On-premise, what you will do? You have nothing, so you have to use Keycloak. So this is why, in my eyes, public and private clouds have complete different architectures, complete different requirements, and you cannot do the same what they do on-premise in the clouds. Okay? So, for instance, the question about Keycloak on public cloud, I get in every project. One single question. So, okay, who will patch it? What happens when Red Hat releases a security patch? Will you wake up at night and patch Keycloak now in the cloud? Can we have rolling update of Keycloak? Is it one Keycloak, two Keycloaks? If there are two Keycloaks, no, where to put the state? If there is one Keycloak, what happens if it dies? After asking this question, we never use Keycloak in the public cloud. For instance, what do we use? We use AD, Azure, or we use Cognito on AWS. It's proprietary, but we can sleep, because then someone at AWS will have to wake up and fix the Cognito. For instance, complete different choice, right? So MinIO on-premise makes sense. You get S3 for free. In the cloud, using MinIO to abstract from different cloud providers, S3 is actually S3 is only S3. S3 is only provided by Amazon. It's a little bit strange, right? So use the real thing. And so I would say if you are on-premise, focus on business logic and enjoy it. So this is you are actually in the best possible situation. And many would like to go to the cloud, so do evaluation first. Spend a weekend with cloud and see whether Monday you would really still would like to have the cloud, right? So this is the idea. So, cloud native. What does cloud native means for me? So first, so no servers. Why? Because if I have servers on premise, why I would like to do the same in the cloud? So if I go to the cloud, I would like to see an improvement. An improvement is, I don't like to care about the same stuff I cared for 20 years on premise. So this is for me not an improvement. Okay? So, then the next thing is, before you do anything, we spend a day on calculator at AWS or the other calculator on Azure to see which service to pick. I think on AWS you can run in Java in 20 different ways. On Azure, maybe 5 ways. And all these services are almost identical. The question is, why are that many? So if we go, for instance, to Azure, this is more visible. The newest services are serverless. Means you pay per invocation. And the older services, you pay the entire time for the hardware. So the choice is exactly, someone asked me, what's the cost structure is. If you are under heavy load, better to pay for the hardware. If you have peaks, serverless is better, right? This is the difference. So, and what to pick is just about costs. So, now it comes for us developers with Jakarta or without, there is a term called marginal costs. So in a current project, one of the current projects, we had a huge amount of money spent in the cloud, like 60K monthly. Developers say it's crazy. But what's the out? The marginal cost means how to call it? How expensive is one call? There's marginal costs. If this call is cheaper than the cloud, the manager says nothing against that. Okay? So what happened in the project, developers were scared, and manager said, it was never that cheap. The first time they saw on the invoice where the money is spent. And they said, okay, the most money is spent on essential use cases. But if we had Kubernetes, they will pay the same amount of money, and they will ask us what runs in Kubernetes. Then we will spend another, or we will have to install kubectl or whatever on Kubernetes to show the management what actually runs on. So it means cloud, the first important thing has nothing to do with our funky Java or Payara, Jakarta E, I look at you, Payara, Jakarta E. So what the main interest is, or the main difference is, the invoice looks different. In serverless, you pay per invocation. You can explain to management. On classic hardware, you pay for the infrastructure. And you as a developer will have to explain management why it is so, at least I was asked the entire time why it's so expensive. So, okay, we could figure it out, but no one knows, right? So the next thing is, no one asked me about that, cloud login. So many are thinking is about code. With Jakarta and microprofile, as I said, really no kidding, our code could run everywhere. So we are absolutely not locked to any cloud. The problem is actually not the source code, the Java source code is solved by microprofile Jakarta E. The problem is, so code portability, not a problem. Infrastructure portability, huge problem. So the networking in Azure is completely different to the networking on AWS. The permissions model I am on AWS is completely different to Azure. And so what it means is our application can be migrated without any problems, but the infrastructure, we will spend days, months, weeks to port it. And this is misunderstood by management, and this is why Kubernetes is still used, because they think if we have Kubernetes, we are portable. But I don't know who actually tried to install Kubernetes in the cloud from scratch. Someone? So I can tell you what happens is you have the first stage is so-called an AWS CDK. So with the CDK, you have the basic infrastructure like permissions, subnets, VPCs, and gateways. And then you have to switch to the second afterburner, CDK for Kubernetes. You install in Kubernetes, and then you spend maybe a week And now we have an empty Kubernetes cluster without permission, without anything. And then we can deploy our application servers. If you go to serverless, there's nothing. Like we had 1995. You have one zip, you push it, and you are done. Okay? And the problem with Kubernetes is, the question is when the nodes are patched. Everyone is afraid, you know. There's a first update when it happens. Except Google, GCP is better. Or it's the best, so far I know. So the long story short is do less, use cloud resources in the cloud, serverless first, and we have almost out of time, right? So maybe what means native, cloud native? So for me, cloud native, what is a cloud? Cloud is a set of HTTP interfaces. HTTP. We almost forgot about that. As the cloud started 15 years ago, everyone talked about, you know, HTTP services. For me, it's important that the cloud control plane and the APIs are accessible through the same cloud channel protocol. If this is true, we can very easily, via the same API, say, give me please a new topic. Give me please a new table. And you get it in a second. So what it means is, if you think about this, Kafka, Postgres, Keycloak, or whatever I mentioned before are not cloud native, because if you provision Kafka in the cloud, you get an empty Kafka, and there is no API to get a topic. Right? So if you have relational database, you get an empty Postgres, and then you have to fiddle with JDBC to fill the database or to set the permissions, or even SSL. But if you have the proprietary DynamoDB S3, you can say, give me a table, 1 second later you have the table. Okay, this is a huge difference. For me, the cloud native means it's not about the software. We also have to use, you know, the control plane has to be also programmable. So I would like to program infrastructure as code the entire cloud. Then it is usable. Without that, forget it. So it is worse than it was before. So with Java EE, what we do, fat monolithic function, we means a microservice, a big one, we package in a Lambda. I use mostly Quarkus. Quarkus eliminates audio reflection, code remains the same, and we can run for cheap, for instance. All my projects look like that. And the question is how I get such projects. Yeah, because I go to management with the Excel, see this will look like this, and we get a project. So this is actually, the first slide is the green, 35 times faster than Python. The next slide is now the AWS costs. And if it costs 10, 15 euros a month, then we have the project. Right? So this is cost-driven architectures. So, and the second mode is the true, I would say, cloud-native function. This is asynchronous. And this asynchronous function is usually a Java POJO, no Quarkus, no Java EE, nothing. And then we pick parts of Jakarta on microprofile. For instance, you get an event if something changed in S3. We get an event with the pipeline starts. We get an event, you know, with DynamoDB streams when something happens. So, and this event is always JSON. So what do you use? We use JSON-P or JSON-B to parse the event. We get nice Java POJO, and from then we are cloud independent again. And this fits nicely with boundary control entity. So we have synchronous functions, which looks like Java EE apps. It's usually Quarkus. And then we have asynchronous functions, which listen to events. And the cool story is both are in the same Maven project. So it looks almost like, 10 years ago, but it runs on the most modern architecture. And by the way, of course, we use Crack and Snapstart everywhere. And on Azure, we use GraalVM to optimize costs. Yeah, and serverless archives, it was EAR, we call it EAR before, and now we call it my invention, service archives, but it's the same project actually. So the project contains Quarkus with several POJOs, and the POJOs are listening to AWS events, Event Bridge mostly. Okay, and this was, and maybe I show you such a function. How much time do we have?
Time's up, but go ahead. Coffee break now.
Coffee break, who cares about that, right? This is such a function. This is a POJO. This has nothing to do with Java EE, but there is also no dependency injection, nothing. And this S3 event is a JSON object. And this works. Most modern APIs don't come with such mappers, so we use JSON-B on JSON-P with, from Jakarta. and there is no dependency injection needed because it's very simple. So what happens here, this event is started, and we call Quarkus or something different, right? So we have two kind of how to call it, endpoints. One is synchronous, always JAX-RS, and the other is asynchronous, is plain POJO, because why to have a Quarkus here, or you don't need, I can just have a very simple code. And you see here this S3 event is extracted, then this function is called, and in one point of time here we have just plain old Java code, which is testable with unit tests. And so what we did, the calculation a lot, if we have, for instance, Quarkus, and we have 2 transactions per second, 2 GB of RAMs, the entire month, it costs roughly $15. If you show it this is for enterprise, more than enough. 2 transactions per second is a lot. Okay, now questions. So it was, we can talk about Jakarta. The code is the same. So whatever I told you the last years is still there. But the cool story is the opportunity for us is to be green, save money, and now it comes, write simple code. And the cool observation is only Jakarta E can do this, actually. Why that? I had heated discussions with cloud architects, and they say, okay, functions have to be small, one function per endpoint, whatever. The problem they have is Python and Node.js have problems. If the application gets too big, it takes long time to boot a function which costs a lot of money. My observation is, regardless how big a Java project is, the problem is not the amount of classes in Java. The problem is the amount of crazy frameworks. But you know my opinion, no dependencies. So if you have just no standard microprofile, let's say, and we have 500 classes currently, no impact on performance. Because Quarkus optimizes, it throws away reflection. Reflection costs money, time and money. And it is fast enough. So we are in the unique position that we can actually build maintainable monolith, so nicely modular, save money, and be greener, because it is always better to have one atomic deployment than 100 functions. So, and the entire discussion is case better. Like, if you think about this, a function with 2 gigs, you get 1 core, 1 CPU. If I have 100 transactions per second in parallel, I get 100 CPUs and 200 gigabytes of RAM in parallel, because it's not a thread, it's a process. So it is crazy. So it scales, you don't need load balancer, nothing. So it means if you mix your knowledge, your Jakarta E and microprofile knowledge, with the latest cloud, services, we can actually provide a huge added value. And what's interesting, if I explain this to companies, they think it's impossible. So I had to show them it is very possible. Now I send him a talk or whatever, because I did already online several times. So look, we can do a proof of concept, but it works. So there's your application, pick it, and we'll launch it as a serverless app, and it's working, right? So people are thinking that serverless is a toy, and they don't know how it works. That's the problem. Questions? It was an almost management talk, so yeah.
One question. In regards to on-prem versus cloud, sometimes when the cost is directly compared based on the machine and the execution and so, or just from your experience, how often do they also include like labor costs and employee and the cost factor? You have this one guy who's taking care of all the on-prem machines, and then he's gone, and you're like kind of screwed. So from your experience, how often does that also compare in the calculations?
It depends, because what usually happens, they know the costs because they hire external developers to manage their cloud, which is not very good for security, right? So this is the weak point. So if the company would manage everything by themselves, this would be the best case. But the problem is, from my perspective, is the bank, should care about banking, not about building a custom hardware to compete with Amazon. Because Azure, Oracle, and AWS, they have custom hardware with custom cooling. And what I observe, no one can compete with them with own data center. You cannot have better or more efficient or greener hardware than AWS, Google, or these hyperscalers. It's over. So what they can have is say, okay, now we have a custom hardware which fits better this use case. This can happen. So if you have no self-driving companies or whatever, and they say, I build my own data center just for that. But this is what not happens in my project. So I forgot, to mention that most of my time I spend in boring enterprise projects. It's not like I'm building, the new, I don't know, OpenAI or something. It's like, CRUD and database still, right? This is sad, but yeah. Yeah. Yeah, and what happens then? They use Kubernetes. It's so expensive that they buy, 3 years in advance the entire hardware because they cannot pay for it, and then it's the entire CapEx versus OpEx discussion over because then I committed 3 years to the cloud and then forget it, right? But with serverless, it's better because, yeah.
Okay. Thanks, Adam.